Hello everyone, welcome to Mizzou Cloud DevOps YouTube channel. Mizzou Cloud DevOps is an online learning platform for application-inspired cloud and DevOps curriculum. Today we will be talking about the 8th lab module of our platform, which is on Prometheus and Grafana that we will show in Amazon Web Services with the video transmission app. My name is Roshan Nopane, and let's jump right into it. So our focus will be on monitoring and alerting, and we will be using applications such as Prometheus and Grafana to do that. And as our use case application, we have a video transmission application. So the purpose of this lab will be to teach learners about Prometheus and Grafana monitoring tool stack and how we can use them to monitor servers and applications. The topics that is covered in this video is how to deploy Prometheus Grafana stack on AWS Cloud, getting familiar with the basic concept of both the technologies and their functionalities. We'll use an example exporter to collect and visualize data from sample application server. And then we will look into how to customize these exporters through a Python program to collect and send data for visualization. And the last topic would be to perform monitoring of video transmission use case application that we will jump into at the end. So Prometheus is an open source monitoring system with a dimensional data model, flexible query language, efficient time series database, and modern alerting approach. It collects and stores its metrics as time series data. That is, the information is stored with the timestamp at which it was recorded. Prometheus includes a rich multidimensional data model, a concise and powerful query language called PromQL. There is a small snapshot of how Prometheus's dashboard looks like. Grafana, on the other end, is a multi-platform open source analytics and interactive visualization web application. As you can see in the snapshot, it has all kinds of different graphical representation of data, be it gauge or line graphs or tables, so on and so forth. Grafana allows to query, visualize, create alerts, and alert the analytics or the data analysts to understand the metrics no matter where they're stored. With Grafana, one can create, explore, and share the data through beautiful, flexible dashboards, as you can see here. We will combine Prometheus with Grafana for data analytics. This stack of Prometheus and Grafana is becoming a more and more common monitoring stack for storing and visualization of time series data. The Prometheus acts as a data storage backend, whereas the Grafana acts as the user interface for analysis and visualization, the front end. You can easily add data source from data source in Grafana, such as you can see, you can pick Prometheus and other useful monitoring tools as well. The use case application of video transmission uses a file that is stored in a server. And then the server will distribute the file to different clients simultaneously and in real time over the internet. The live stream video is used over socket in Python 3. The streaming is the continuous transmission of audio and or video files from a server to a client. A live video streaming application can be used for the purposes such as surveillance, traffic monitoring, and etc. A media file or a video is going to be played on the client device, which is stored remotely and is transmitted a few seconds at a time over the internet, which will be the source of our metrics or the data. The test bed of our lab today will be or is built using Amazon EC2 services. The video transmission application simply has a server and a client where we will be using a Prometheus exporter to send to a different instance from which we're going to use Grafana and Prometheus to visualize the data. So the files that we created to perform this transmission of data and delivery of information from the server to this client basically is written in Python programming language. Okay, so the use case application, like I mentioned earlier, of the video transmission is built off of a project where we will be exposing two of the metrics called Fabric HTTP bytes and Fabric stream duration, which will basically be the packet size and the duration of the stream. And these are captured in the log. So as we will move on to the use case application, you will be able to see some of these snapshots that you are seeing here in your Prometheus dashboard, where you can query the Fabric HTTP bytes sent in total and Fabric stream duration sent in total. And using those information, we will be posting the data in Grafana, where you can visualize, such as in this context, we have this line graph. Okay, before going to the demonstration, I just want to quickly give the overview of what we're going to do in this lab. Again, we will be deploying Prometheus Grafana stack on AWS Cloud. We'll go over basic concepts and functionalities within these technologies. We will be using example exporter to collect visualized data from sample application or server. We will be programming a customized exporter to collect and send data for visualization to Grafana, and then perform monitoring of video transmission use case application. So if you have not already, you can access the lab instructions at www.mizzouclouddevops.net. And let's jump right into the demonstration now. So remember, we will be using EC2 services within the Amazon Web Services console or the platform. Clear the screen, and then I will be using the wget command to copy all the related information or files for us to run Grafana in the server. Right, it was fairly quick. So again, similar to the earlier process of downloading Prometheus, we can see we have Grafana downloaded now. And what we want to do is again use the tar command to unzip the Grafana file or the compressed file. So we will be using the tar command, and again follow the instructions in the instruction page from the portal. And Grafana has a lot of underlying services and files, so it might take a few seconds here. Okay, once we see this $sign or this Ubuntu and the IP address, it means that it's finished. So I'm just going to clear the screen to make it more clean. And next I will be saving some values to a couple of variables. Remember, we used export earlier to do that, to save the Prometheus version. Similar to that, I'm going to save true value into this variable, which is AWS SDK load config. We'll be using this in a bit, so while running the Grafana server. So let's just do that and then further save another value of true to this variable here by using the export command as well. Now, for us to be able to run the Grafana, what we need to do is locate this folder that we just unzipped, which is called Grafana 7.3.6. And then for that, we will have to do cd and then Grafana. All right, so this will take us into this folder. If I list here, you will see a few things. What we need to do is find a executable which is inside this bin command, folder, and to access this, what we will do is use the same command of /. We will locate to the bin, and inside of bin we have this Grafana server, and we'll just run that. So once you do that, it will be running, and what we have is that Grafana is by default hosted in this particular port 3000. So we will use 3000 as port to connect to the Grafana server, and by using the public IP address and followed by the port of 3000. Okay. So see, as you can see, you have access to the Grafana dashboard now, which is all hosted in your own local instance or cloud hosted instance. The credentials to log into Grafana by default is going to be admin. You can feel free to change that if you want, but you can skip it because we don't necessarily have to change this to perform this tutorial. So I'll skip this and it will take me to Grafana. So that means we've successfully installed Prometheus and Grafana into our EC2 instance. Now that we've installed Grafana and Prometheus, we will look into how to query metrics in Prometheus next. So from this search box here, you can type in Prometheus, which will list a bunch of metrics for you to look at. Some of them are gauge, some of them are counters. And again, that would depend on what type of metric that you're going to expose and all those things. So what we're going to do is look at a specific metric here, which is called target interval length seconds, which will, when we click on execute, then it will show the interval lengths. And again, so by this you can list different metrics of different values, as you can see here. Along with that, you can also query or like use some filters, which is achievable by providing some values, such as, for example, we have this quantile. Let's just pass a quantile value as, let's say, quantile equals to 0.99. So it will look for all the entries for which the quantile is 0.99. So when we run that, for now we can see that there's one entry here, so it should just be filtering out this one entry. So if I execute, as you can see, it just showed that particular value. Right, so that means we have simply explored how to locate some metrics. And again, Prometheus has a bunch of metrics for us to test, which is out of the box. So as a simple use case or like simple example of how you can run Prometheus, I wanted to showcase this. Now you can see that there is table and then there is graph. So you have representation of values by either a tabular view or a graphical representation. So you can see in graphs, we have this line graph showing this particular metric that we have here. So yeah, that's pretty much it. So you're able to simply locate metrics by using Prometheus. And now the next step in the 3.2 section in the lab instruction of the monitoring chapter, what we will do is use metrics from the node, which is our EC2 instance itself. So for us to do that, we need to create a node exporter, for which I will initiate a new instance here. So I'll hit connect. to create a new instance of the EC2 instance that we have, but just a terminal instance, not a new computer. So, okay, from here, I'm going to export some values such as a version for node to use, which is simply going to be used by using the export command. And once I do that, that saves it in that command, and I'll get the Prometheus node exporter from GitHub repository using wget. So here it is. So I'm using wget to get the Prometheus node exporter of a certain version of 1.3.1. When I press enter, it should be able to download it. And once it is downloaded, you should be able to see it here. So the node exporter can be seen here. Again, following the similar process of using tar command to unzip this file, I'm going to paste the command from instruction and hit enter, which will simply export or let's say unzip this tar file into a folder. So when I do a list, I can see this new folder created here, which is node exporter. And again, for easier access, I want to remove this trailing versions and everything. So for that, similar to earlier, I will use move command. Right, so move using the same value as this and then saving it into node exporter. So to test that, it has changed the name. I'll just list, and you can see the name has been changed. Now, for us to start the node exporter, we can go to the node exporter folder and then list it to see that there is this executable called node exporter. For that, we need to use // and then node exporter, which will basically mean that we're running this command. Right, so since I have created this node exporter, it would mean that it will generate, use the exporter to generate metrics and use it for us, for our usage, basically. This is generating the metrics here. We're going to create another instance of the terminal by using this same page and then hitting on connect. We will be using a bunch of different terminals to be able to simultaneously work on different items, such as running the servers in the background and doing something else. Now we're going to use a curl command to be able to view the metrics that has been exported. So for that, I'm going to simply copy the command and paste it here. So as you can see, there are a lot of metrics being collected here. What we want to do is make sure that there are some information relating to the node based metrics for our use that we're going to pull into the Prometheus later. So for that, I'm going to copy this command from the instruction, and I'll just grab the node underscore, which will highlight all the metrics that has node as the prefix. So as you can see, this red color represents all the node related metrics. So now what we want to do is use Prometheus to pull this information through a certain port. Now what we'll do is we'll have to go back to the first instance where we've had this Prometheus running, right? We had this Prometheus.yaml. I'll simply terminate this because I want to change the configuration file. So for ending this, I just hit Control-C. That just terminates the process, and I don't have to create a new instance to reinstall or rerun the Prometheus. I can do it from this already there instance. So let's see what is there in this folder. There is this file called Prometheus.yaml. We need to configure this file to point to a different port from the usual. Usually we were using the 9090 port, if I'm not mistaken. Yeah, we were using the 9090 port to pull the information, but this time around we're going to use a different port to collect different data, let's say. So by using a nano as a text editor, I will go inside of this Prometheus .yaml file. As you can see, there is a bunch of information here. And again, we don't necessarily need to change any of the information here except for these targets. But feel free to change it as per your use case. If you're using Prometheus, you should be able to configure Prometheus as you wish. So I'm going to simply go to the static configs section, and then from here I'm going to change the score to say 9100. Okay, so this is where our node information were stored or like being exposed from. So for this, I will be saving this. Once I make an edit, if I exit, it will ask if I want to save. If I say yes, then I can basically save in Nano. So once you've done that, if you use cat command to what is there inside this YAML file, you should be able to see that we had updated the port from 9090 to 9100. So this means we need to reconfigure Prometheus to point to this target, right? So for that, we will be using a command similar to what we did earlier, which is running simply the Prometheus executable and using the configuration as the newly updated prometheus.yaml file. So once I hit enter, it restarts the Prometheus, right? And then it simply goes to start, like we can now start the Prometheus server here. So if I refresh this, as you can see, we're here. So from here, I could simply type information such as node, right? We try to get information of node. So if I collect, like when I type in node, it will collect a bunch of node related metrics here. For us to kind of get the idea, we're going to select the CPU seconds total and simply hit execute. So you can see that the time CPU took to be idle or like, in IO wait state or some other different mode, we have all the information logged here. So this simply shows that we were able to export node related information, which is our CPU related information, into CPU or other resources relating to our EC2 instance into Prometheus as such. Now let's also visualize this in the Grafana. So as you recall, Grafana, we already connected the Grafana here. What we need to simply do first of all is configure this, right? So we need to configure this to allow Prometheus to send data to the Grafana server. So from this gear item in this gear icon in this left navigation, you can click on the configuration and simply say add data source. So like I showed earlier in the presentation slides, you can simply see that Prometheus is already listed here. What we need to do is select this, and it says the data source has been added, right? So for us, the local host 9090 is the default URL, so we're going to keep it as such. Apart from that, everything looks just fine. So what we will do is now save this to test it. Okay, it says error bad gateway. So maybe because there is no information in this URL. So let's just type in the same command. I thought this was going to be by default, but never mind. So let's just type in localhost 9090 and then try to test this again. Okay, so this data source is working, fortunately. So that means we have a data source, right? Now we want to visualize this, and to visualize, what we can do is use this plus icon to create a new dashboard. So when we say create new dashboard, we can add new panels as such. So when I hit new panel, it will show this this page here, which allows me to perform visualization, which again are of various types that I mentioned earlier. There could be tables, graphs, gauge, heat maps, and a lot of different ways to visualize your data. So let's just stick to line graph for now. And from this source of default, what we want to do is drag and then click on Prometheus. Now we have this filter or this query section here, which is a PromQL based query language based way to showcase the metrics. And from this metrics, I'm going to navigate to say node. And recall we were using the CPU seconds total earlier, so I'm just going to click on that. So see, we had just started a couple of, maybe a minute ago to start fetching the information for the node information into our Prometheus. So it started showing here. So if you want to enlarge this, it also allows you to flexibly change the time here. You can show the last 5 minutes, which means that it will show the most recent 5 minutes of the data being populated. And this simply shows that we're able to visualize the data. So yeah, by using node exporters, we were able to visualize this. Okay, now that we've showcased how to export information from Node into the Prometheus and then to visualize that using Grafana, let's move on to using a custom exporter developed using Python code. We have a readily available code that we are hosting in GitHub, and we're going to use that to get that information. So for that, what I'm going to do is, again, go create a new terminal and download simply the custom exporter that we have. So use the git command on the 4th chapter to clone to the Prometheus custom exporter that we have, which is hosted in our GitHub channel of Mizzou Cloud DevOps. And we're also going to install Python in order to run this file. Okay, I ended up copying the same command. So let's install the Python command by using apt-get command. Now we are able to install the PIP, which is the package manager for Python, and we will use the Prometheus client. Before that, let's just say yes to continue to do this. And once this is dealt with, you will be able to install the Prometheus client for this exporter. Okay, if you see the screen, just simply press escape just to get out. You don't have to configure anything else. Okay, so once you hit escape from there, you should be able to see again the command has completed, so it's reverting back to the default here. I'm just going to clear the screen, and now I will install Prometheus client. To do that, I'm going to use the command pip3 install Prometheus client. Okay, it successfully installed the client here. So now if we list the items, you must have had this folder downloaded from the Git repository that we did earlier by using the clone command. Let's go to that folder to access the custom exporter. Okay, so here you can see there is this log exporter.py and random number.py. So by looking at the random number.py using cat function or the command, what we can see is there are a couple of metrics that we're going to use, which is called random number and total random number here, which are basically a random number gauge and a random number counter. And again, to showcase this, we'll be hosting it in the port 9001. Okay, so now that this has like, once you go over this, you should be able to see how you can create your own custom exporter and feel free to use it for your use case. Now let's just run this command. The Python file. And once we do that, it should be generating data. Now, for you to visualize, remember, we're going to see it in the port 9001, right? So if I go to this IP address, and then go here, and then see 9001. So look at this. So every interval of maybe 15 or so seconds, what it does is creates a new value, or like randomly generates new values, and then it just gets listed here. So every time I refresh this, it should show some random different values here. And again, if it's within the 15 seconds range, it might just stay the same, but as you can see, these values are being changed. That would mean that we are able to generate data using the random number. So again, recall that we have to host this, or like expose this data into the Prometheus. So we're going to go back to the initial console where we had the Prometheus running. So we need to reconfigure the YAML file to now expose the information created in the 9001 instead of 90 or 9100. So I'll just terminate this by using Control-C. So you can see that the service is not running anymore. Now what I will do is simply go back into the Prometheus YAML file. Okay, and from the static config's target value, I'm just going to change this value to say 9001. So this will, oops, just give me 1 second. Okay, so for you to save, just hit Control-X, that will exit, and then ask whether or not to save this modified buffer. You should say Y, that is yes, and press enter. So it will simply save it. You can recheck that by doing the cat command and then entering the file name to see what is in there. So now that we have configured Prometheus to point to a different target, what we're going to do is reconfigure the Prometheus. Yes, and then we're going to use config.file, or that will be Prometheus YAML. Okay, all right, so once I hit this, it will restart it and simply point to the 9001 that we had. So it means it should be able to now run to collect the information from the system to generate, or like collect the random number related values. So what I'm going to do is simply go over to this search bar to type in random. So you can see that there is two different values that we just created. One is a gauge and another is a counter. So if I simply go to random number, it should be able to show the value that we have extracted. Currently, the random number is showing as 5, which is good. And now what we're going to do is check the random number. Let's search for random again. Let's try again. Random number to total. So if we go to this one and execute, we can see the values for the other metrics here, which is 67 at this point. That means we were able to collect information into the Prometheus. Now, doing the same thing in the Grafana dashboard, we will be able to populate the new data, the random related data. So let's just go back to check the Prometheus data source. We can discard the dashboard. If you want to keep, you can create new dashboards as you like. So our data source is Prometheus, so which means we are pretty much set for this. So let's just create a new dashboard again to add a new panel, and simply as earlier, we will select Prometheus from here, and then from the metrics we'll collect random. So as you can see here, there is two different metrics for us, which one is random number and another one is random number to total. So we're going to select the random. As you see, the values keep on changing every seconds, or like a certain like custom number of time, or like time duration. If you want to just check the last 5 minutes, you should be able to see all the random numbers generated at the different timestamp, which is at this point it's 14, then there is 5, and then 3. So it just keeps on changing as how the system is defined, or the Python script is defined to change. So this would mean that we were able to simply see this information. If I go to table, you can see that the timestamp and different values here. Okay, that means we have information and about this this random number. If you want to check for a different metric, you can go to the random number total, and you will see the counter that keeps increasing. Okay, so that showcase our custom exporter, how you can utilize custom exporters to use in Prometheus and Grafana. Okay, now as the last section of the use case application that we were talking about, the video transmission application, we're going to now use a different instance to begin with. As you might have recalled, we had created instances. We had some key pairs and security groups created for creation of instance. So we're going to stick to the same key pairs and security groups. So let's move on to just simply creating a new instance from by using launch instance. For here, let's just call this fabric server PG. Okay, so and from here we want to do what we want to do is simply select Ubuntu again and stick to whatever is there by default, and leave every other information the same until the key pair, where we will be picking the key pair that we had created, which was, I think, key EC2 Prometheus. Yeah, so this was the key that we created earlier. And then from the security group list, we had SG underscore Prometheus. Right, so this was the security group we had created earlier. Again, other values can stay as default. Again, make sure that your details are correct here, and then simply hit launch instance. This shouldn't take too long. This will simply create a new instance. What we're trying to showcase here is we showed how to collect information from within an instance, but we're going to try to pull some information from a remote server and then showcase in a different system. So for that, so now that the instance has been successfully initiated, we're going to connect to this instance. Okay, so this is already running. It has a different IP address, as you can tell. So I'm just going to hit connect here to connect to this new instance, and new again, make sure the name is Ubuntu, hit connect. If it's loaded properly, it shouldn't fail, but it might fail. So if it fails, just give it a few more seconds. But yeah, for our instance, it has already been connected to the computer. What we're going to do is install some required information here. First of all, we need to check if we have Git. Hopefully we already do. So as per the instructions, you're asked to install Git, but you already might have had Git installed here, so we don't necessarily need to install again. If not, you can do sudo apt install Git. Now let's continue to install all the related libraries that we will be using, such as pip to again connect to the Prometheus client like we did earlier, and use libg for OpenCV, which is how we are transmitting information. So just simply copy the information from the 5.2 in your chapter 5 in the module, and you should be able to install all the dependencies. Okay, the first one was that we're going to add a new repository called universe. Right. I press enter to continue to do that. And once I have this readied, I will simply update my apt-get to reflect the new changes. Okay. To do that, I'm going to use the sudo apt-get update command, and it should be able to update the package list. Now, what we need to do is install Python pip, like we did earlier in the other instance. So it takes some amount of your storage. So it asks for the question yes or no. You simply say yes. Similar to earlier, this screen pops up. We don't need to change anything here. Just press escape and you should be taken back. Like that. Now that this has been completed, the next step would be to install the livg dev version. These are all the related libraries and modules that will be required for this use case application. So some of these libraries may not make sense to you, but they are actually working in the background to allow us to run this video transmission and also perform the exporting of the information from them. So the next step would be to install a couple of Python packages. First is NumPy. Another one is OpenCV Python. Another one is similar to what we did earlier for the other instance, which is Prometheus client, and finally gdown. Gdown is simply used to collect information or like download file from the Google Drive. All right. So what we will do is collect some programs or like executables from a GitHub repository that we have, which is going to collect the file called send frames over TCP. So we're going to simply collect that, and once we've done that, you should be able to see that folder that we just downloaded. Now let's go inside this folder. There are a few commands like programs, Python programs for us to run and like transmit the data. So what we're going to do is download a new file from in the internet. So for that, we just use the wget command. Okay, so we're going to download this file called friends.mp4 from a Google Drive, and once we do that, we should be able to see that downloaded in this list. Perfect. So it should be saved. So if I list the files here, I can see that there is friends.mp4 that has been newly created. Okay, so when we transmit this, we need to make sure that Prometheus is configured to pull information from this. So we're going to go back to the other instance, right, where we had the Prometheus installed, running, from where we're going to simply terminate that instance of Prometheus, and then now reconfigure the YAML file to point to the IP, point to the EC2 instance that we created earlier. So to do that, I'm going to type in nano and then prometheus.yaml. So notice here we're using targets as localhost and the port within this computer. That means we're using the same EC2 instance that we were showcasing in the node, exporting in the custom exporter and everything. But for this instance, what we're going to do is point to the EC2 instance of the instance that we had created earlier. So remember, we had this instance that we created, the second one. Copy the IP address of this, and then simply go to your Prometheus configuration, that is the YAML file, and here under the targets, paste it where the local host is. Oops. Okay, so if I paste it here, it should point to the IP address that I was using, and the port we will be using for this is 9002. Okay, to save this, again, Control X, and then when it asks for whether or not to save the modified buffer, we're going to say Y, that is yes, and then we press enter to get out of this. Right, so now that we reconfigured it, we want to rerun the Prometheus YAML as a configuration file. So for that, we're going to use the same command as earlier, and then run the Prometheus. Perfect. So now we want to run the video transmission application so that we can continue to send information, or like we can start sending information to the Prometheus server. For that, what I will do is I will go back here. As you can see, there is this folder called send frames over TCP. If you're not inside of this folder, just click cd space the name of the folder, and you should be able to go there. So again, relisting this folder, we have all the different files here. What we're going to do is run this code called vidd.py, which will simply start transmitting the information. Okay, so let's just use Python 3 to run the vid.py file. It should start listening. So it has been listening to anything that is coming, so that it can post it back using the Fabric exporter to the Prometheus server that we had created, right? So leave this instance open and go back to reconnecting to a new terminal instance. We're going to run the Python player to start sending information. Okay, so we're going to list what is there. There is this folder called send frames over TCP. We're going to navigate there. From here, list all the files, and you will see that there is this client player.py. So that's the folder. That's the executable or the program that we want to run next. So what we're going to do is simply run Python 3 client player.py. And again, if you want to see what's inside of these Python scripts, feel free to do a cat or nano and go in, and even if you want to change things here and there, you can play with it. But yeah, for this tutorial, I'm simply going to stick to just running this for now. Now leave this console running also. It's collecting data, so let's just create another instance from where we're going to now use the exporter.py file to collect information, right? So let's go back to the send frames over TCP folder. From here, you can see that there is fabric exporter.py. We're going to run that program. Okay. So once I do that, it will collect information such as the duration or the throughput and the line numbers. So these are all information that we're going to send to the Prometheus folder. So this is running. Let's just go to see the Prometheus server that we ran, which means here by refreshing this, and now let's locate some of the information related to Fabric. See, you can already see that there are some values that we've sent. I talked about the throughput, the duration, right? So it's already here. So what we're going to look at, the first is the bytes sent total, and we're going to execute it. So yeah, so you can see there is some values generated, and it's also coming from our instance, the second instance that we had created. So we were successfully able to expose all the data to Prometheus. Similar to this, we're going to check the stream. We're going to check the stream duration total, which would be Fabric stream duration total. So if I execute this command, it will show this metric value. Okay, now let's go to Grafana to create another dashboard. Maybe we'll go to configuration and discard this change for now, and then simply go back to create a new dashboard, add a new panel, and similar to earlier, we're going to look into the Prometheus as the data source, and in the metrics, we're going to locate Fabric. So you can see there are information related to Fabric here. So from here, we can take a look at some of these metrics that we had just passed to Prometheus. So first of all, let's just see the stream duration total. We just started doing this, so I'm going to shorten the length of the time to 5 minutes. So now you can see that we have like the information from the transmission. So like it shows the stream duration, for example. All right, so yeah, this pretty much is the lab module. Hope you got to learn something new today. And Prometheus and Grafana are really cool tools for you to monitor and visualize your data, and are very easy to configure, like you already noticed today. So yeah, thank you for listening, and please check out the Mizzou Cloud and DevOps.net portal to access this lab to run. Thank you.